wonder what a flying car looks like and how it works? Or are you interested in pursuing a career in STEM but just don't know where to start? Or are you just looking for a meaningful way to spend your dream holiday? Learn from some of the best in the aviation industry as they share their amazing career and the exciting experiences that they have. Explore with innovators and entrepreneurs as they come up with exciting technologies to revolutionize the field. And hear from educators who bring science to life through experiential learning. Aspire Week is here to inspire you. Join us online from 14th to 20th June. See you soon.
Hello and welcome to Aspire Week, where we explore flying cars, innovation and technology, and careers within the aerospace industry. In this session, we have Mr. Nicolas Ang, CEO and co-founder at F Drones. Nicolas, welcome to the show.
Hi, Johnson. Hi, everyone.
Nicolas, you spent 12 years at the Singapore Economic Development Board, setting up space technology industry offices, transformation of Singapore marine and offshore industry. What made you decide how did you start F Drones?
Well, I've always had the passion of wanting to build something that could fly, something that's innovative, something that's out of this world. And I thought that if we don't give ourselves a chance to try it, then we may never have the chance. So that's why I co-founded F Drones with my partner, Yeshwant, in 2019.
Thanks for that. We look forward to hearing about you and your journey. So I now leave you to share more, and we'll be back with you at the end after the presentation for a Q&A. Over to you, Nicolas.
Okay. Thanks, Johnson. I'll share my screen now. Okay. Can you see my screen?
Yep.
Good. Hi again, everyone. I'm Nicolas, the CEO and co-founder of F Drones. We are a Singapore-based startup, started in 2019, just slightly over 2 years ago. And our vision is to make the world's maritime logistics a lot more efficient and sustainable. And that would be done with our proprietary drones, which would ultimately be able to deliver payloads of up to 100 kilograms over 100 kilometers. So this is a very exciting field for us, which we want to really bring a lot of innovation to the market and everywhere around the world. So today, I'm just here to really share with you what I know about drones, about how drones have evolved from what they were to how they are being used today, and what does the outlook of the drone market look like in terms of the adoption rates, how they're helping people, and what are some of these technological innovations that are happening, and how these could potentially affect you or even provide you with career opportunities in the not so distant future. So to start with, I thought that maybe I would first talk about what exactly an aircraft is. I mean, we've all seen planes flying, helicopters flying, but just getting to know some of these terms could be useful for you in the longer term. So broadly speaking, aircrafts are divided into two types. The first type is really what we could coin them as Aerostat. These are lighter than air aircrafts where they use buoyancy to float in the air, meaning that the whole aircraft, together with the air that they are filled with, such as helium or hydrogen or hot air, makes them actually lighter than air, and they float by virtue of being lighter than air. And there's another type of aircraft called aerodynes. This group of aircrafts actually are heavier than air, but they make use of blades, wings to push the whole aircraft upwards using what we call lift. Lift is really a magical term in the world of aviation, where it's a force to help push the aircraft upwards so that it continues to stay in the air for the long term. So remember this, there are broadly two groups of aircrafts. One is those that are lighter than air, and the other group are those that are heavier than air. Of course, today we see a lot more aircraft that are heavier than air, and a lot more drones are actually belong to the aerodyne category. So you may ask, what exactly is a drone? What is an unmanned aerial vehicle? Drones can mean many types of unmanned vehicles that are sort of unmanned surface drones, drones that go onto the road. There are also unmanned underwater drones, like underwater submarines. And today specifically, we are going to explore a little bit more about unmanned aerial vehicles and how we define a drone, an unmanned aerial vehicle, is that it is an aircraft where there is no human pilot, there's no crew or passenger on board the aircraft itself, and it can be operated under remote control by a human operator, or operate by itself without any assistance from any humans at all. So that's the definition of drone. I'll touch a little bit more about how drones came about in a couple of slides. But before that, I thought it'd be useful to share with you on what are the types of drones out there. We've heard about drones, we've seen some drones, some of us have seen drones that take photos, some of us have seen drones that, in the movies where they strike some of the enemies and things like that. But these four categories are really the broad categories of what drones are. There are the single rotor drones. These look pretty much like helicopters that make use of one rotor that rotates. And they are pretty efficient in a way because they fly like helicopters. And there are the multi-rotor drones. And these are the drones that have multiple rotors that continuously spin to keep them afloat in the air. So today, I think a lot of us would have seen many different types of multi-rotor drones, including those that we can buy, from a shopping mall to take pictures, or some of these racing drones. They also have these sort of a multi-rotor configuration. Then there are also the fixed-wing drones. We see these quite a lot, and these types of drones just uses their wings to stay afloat by going fast in the air. And increasingly, we are also seeing a lot more of what we call the hybrid eVTOL drones. This is a very exciting field. eVTOL is a relatively new term. I think it has only just become more commonly heard over the last 2 years or so. And this is a section that's very interesting because they make use of both the fixed wings to allow them to fly further and faster like aircrafts. But the problem with aircraft that is fully fixed wing is that it actually requires a runway to take off and to land. And in today's drone applications, there are a lot of areas where we don't really have the luxury of having a runway. That's why delivery drones in particular are actually looking a lot more at these eVTOLs, these electric vertical takeoff and landing types of drones, where they can fly further, faster, with heavier load, but at the same time be able to take off and land vertically to be able to deliver these items in very sort of urban environments as well. So how do all these drones, how have all these drones come about? I mean, if you were to take a step back in time, 300 years, more than 300 years ago, actually it was started in a way based on how we define a drone, where a drone is unmanned and can be controlled or uncontrolled. It was really, in a way, started by these Montgolfier brothers in France when they first started to experiment with how balloons could be used for manned flights for themselves. But as a start, they of course didn't want to risk their lives and go onto the balloons first. So they actually put up an unmanned balloon to start with, and that really propelled all the developments further down the road around how such systems can be unmanned and used for various types of applications. And then it was not until more than 130 years later when we really have the first controlled aircraft or a radio-controlled drone in 1917 when the British actually developed the first of such aircrafts. This was during the World War I, but it wasn't used during the war itself because it was still a very new thing, and they were trying to find out and figure out how effective they could be. But it was brought into action in the 1940s under Operation Aphrodite, when the Americans actually used for the first time remote controlled bombers, loaded with explosives to hit, enemy facilities that were so hard to get to during the war. And because of this very advanced technological development at a point in time, it actually helped to, in a way, turn the odds against their enemies during that World War II. Fast forward to today. I mean, it's been more than 70 years since the 1940s. Well, today we see that, about 7-8 years ago, drones have really become more and more popular. They're increasingly being used in various types of applications, and in particular for recreational use. I mean, a lot of people today can actually just buy a drone from a shopping mall or a shop somewhere, or even online, and use this for photography. You can use it for filming and things like that. And drone racing has also become more and more exciting these days. So drones really have become a lot more prevalent in our lives now. And more companies, more and more people are finding different ways of using drones because they are very useful in various aspects. For instance, in 2016, this company called Zipline, they make use of a fixed wing drone to actually deliver medical supplies, medicine, and even blood to patients in Rwanda. And it was really the first of its kind at that point in time. And today, this has actually been used in many other countries, not just in Africa, but it's really a way where we can bring about, some of these medical care, some of these time critical or even temperature sensitive items across remote parts of the world. We also see that drones are also being used to deliver vaccines to areas which are inaccessible and difficult for those people to really come to the city to get vaccinated. So this is a very exciting field, and I think that there will be more and more of such applications in using drones for medical deliveries. And not just in the medical deliveries, we are also seeing drones being more commonly used in different kinds of sort of a commercial or e-commerce drone delivery, parcel delivery. And the regulations are actually, in a way, also advancing along with that, where, last year in the US, the FAA, which is the Aviation Authority of the United States, they actually, for the first time, granted a company with the license to fly beyond visual line of sight on a block basis. So this is a very exciting time because this means that there could be more and more what we call long distance e-commerce or last mile drone deliveries that's going to happen over the next couple of years. It is still an evolving space. I mean, we still don't see, delivery drones around us, whether in Sao Paulo or in Tampines at this point in time. But we think that there are opportunities in this area for drone deliveries, not just within urban areas, but even for businesses in B2B application areas. So if I were to just broadly categorize them into, today's use of drones, I would broadly say that they are being used in 3 types of application areas. First is in consumer. More and more people are able to access drones. 2 is in military. In the military space, drones have been used for quite a long time. In fact, the military drones are very, very advanced today. And thirdly, in the commercial space, which is becoming more and more exciting because drones have become more and more capable. And now businesses are also starting to see the benefits of drones. In the consumer space, I don't think I need to talk too much about this space. I mean, we can use a drone for photography, to make videos. Sometimes, even nowadays during Formula 1 races or even in soccer matches, you see some of these drones flying around, taking these live scenes, and it really makes the whole experience, it makes all the photos a lot more exciting and beautiful to see. And in the military space, like I've said, they have been used for quite a number of years. They are very advanced. I mean, drones like the Predator can hit their targets when the pilot of the drone is actually sitting more than 1,000-2,000 kilometers away from the target itself. So this is very interesting because it allows for these kind of missions to happen without putting the human at risk or the pilot at risk itself. We are also seeing more and more innovations happening in the military drone space. For example, this Black Hornet is such a tiny drone where it is used by the special forces to fly into a room which is potentially dangerous, or there could be terrorists in the room. Without having to put someone's life at risk to go into that room first, they can actually use this drone to go in first. I'm not sure if you guys watch Spider-Man, but also Spider-Man also has its own drones called the Spider drone. It looks like a spider, and he actually sends it into some of these dangerous spaces before he himself goes into those spaces. And there are also other drones used for better assessment damage, for this damage assessment, as well as for long distance, long period of time kind of a surveillance and to gather intel across different parts of the world. Sometimes these drones can even stay in the air for more than a couple of months. And that's really the power of how technology is evolving in this space. Besides military applications, like I said, the use of commercial use of drones have become more and more interesting. There are pull and push factors to why people are using drones more and more. Some of the push factors, I would sort of in a way group them as these push factors that are dull. I mean, jobs that are dull, dirty, and dangerous. The 3Ds: dull, dirty, and dangerous, where these jobs which were traditionally being done by people can actually be done by drones more efficiently and remove the human from the risk itself. For instance, in firefighting operations on a very, very tall building, instead of putting a firefighter onto a ladder more than 60 meters high and trying to fight the fire, they could actually use a drone to do that without having to put a human at risk. These are really, really dangerous jobs. And there are also other jobs that require, say, humans to inspect, say, 30 kilometers of pipeline, trying to find, small cracks around it, when you can actually use a drone, automate it, train it to be smart enough to find where are some of these cracks. And then immediately, once upon identifying these cracks, tell the drone operator where these cracks are, and quickly go down and repair or reconcile the situation. So these are some of the dull, dirty, and dangerous jobs that can increasingly be done by drones at a pretty low cost also. So these are the push factors as to why more and more companies are making use of drones compared to using humans for these tasks that were done for the past many years. There are also the pull factors, which is making companies more and more interested to use drones, because drones have the potential to reduce the time and also the cost of doing those jobs. And increasingly, because drones are using batteries more, in the past they have been burning fuel and other types of dirty energy sources. But increasingly, because it's electric, companies also see it as a potential use where they could help to be more responsible to the environment, such as in the development of electric air taxis. This is a volocopter, and the use of air taxis is going to be very exciting, because imagine, if you are, say, living in Pasir Ris, and maybe 2 years down the road you are going to study somewhere at NTU, which is going to be like 35 kilometers away, and taking an MRT or driving there is going to take you easily 1 hour. But with an air taxi, you can actually reduce the amount of carbon that's being produced for that trip alone, and certainly easily half the amount of time that you need to get to that destination. There are also increasing users of drones in different types of deliveries, not just delivering people from one end to another, but also delivering items that are critical to businesses, as well as consumers also are thinking of how drones in a way can help them get access to some of these products or services which they previously couldn't. And that's why you see in different parts of the world, some of these companies like Amazon or Google, they are actually testing out how drones could potentially help them acquire more customers. Of course, It's still a new space, and a lot of innovation needs to happen before this can be really proliferated across different parts of the world. So at F-Drones, we are also similarly tackling this problem where we think that drones have the potential to help reduce the time, the cost, and the CO2 emissions, specifically in the marine and offshore applications. So what we realized is that delivering supplies or critical items to these boats, that are anchored at the East Coast area, and also in ports in many parts of the world, are actually quite expensive. They're pretty slow. I mean, these boats, they travel at about 25, 30 kilometers per hour. Sometimes if you travel from a jetty at Marina South area to get to a boat that is around the East Coast Park area will easily take you, 1.5 hours or even 3 hours, for a round trip. And they produce a lot of CO2. A launch boat produces more than 6 kilograms of CO2 every kilometer it travels. And a helicopter produces easily 3.5 kilograms of CO2 every kilometer it flies. And you would imagine that a helicopter you would usually fly a lot further than a boat. And the boat itself already produces so much CO2. I mean, just imagine if it was a round trip of, so say 20 kilometers for this delivery to a boat that's anchored somewhere near the East Coast area. 20 kilometers back and forth would be 40 kilometers. And the amount of CO2 that it produces just for the trip is already heavier than me as a person already. So there's a lot that drones can potentially do in helping to reduce the amount of CO2 for the environment that is emitted to the environment. But what we realize is that, drones, yes, they have the potential to change this. They are not yet there. They are not yet good enough because the marine and offshore sector actually requires drones to be a lot more capable. They need to be able to carry a lot more weight and fly over longer distances. And the typical drone that we can buy off the market today can, usually only deliver like, say, 5 kilograms of payload over 5 kilometers. And that's already a very good drone you can buy off the market. So there's a lot of innovation that can happen there. And this is why we have designed and are developing our own proprietary drone, a drone that can deliver payloads of up to 100 kilograms over 100 kilometers. And most importantly, we can help people save time, save money, and also save these CO2 emissions. This is a very unique aircraft type. It is a tail seater, meaning it sits on its tail during takeoff. So it will look like this, taking off vertically from the ground with its fixed wings and 8 propellers. Then it will rotate to fly like a plane with its fixed wings. Remember, I mentioned that fixed wings can fly a lot faster and further compared to those multicopters, those helicopter look-alike kind of drones. And then it would transit to land back vertically on vessels, even when they are moving. And there's some kind of machine learning that we are teaching this drone as well, so that it can be able to automatically find out where a ship is and where on a ship is safe for it to land on. So these are some of the things that we are doing. And I mean, one of the key reasons why we are doing this is because we have seen that the commercial drone market is really, really taking off. I mean, it was almost worth $0, just about 10 years ago. But as you can see in this chart, in these dots in green, I mean, in 2016, the market for commercial drones was only $0.6 billion. But today, it's already 4 times of that. It's worth about $2.4 billion. So it's a growing market with a lot of opportunities. And as you can see, also on this chart on the right-hand side, by 2025, this market is going to grow by 5 times to $12.6 billion. So there's really a lot of opportunities in this sector, which mean that there would also be a lot of new and exciting jobs, a lot of new innovations that can happen in here. So talking about innovation, I thought, I mean, there are a lot of innovations happening in the world of drones, in the world of unmanned aerial vehicles. But I thought of touching on some of these points because these are really, really quite critical towards the progress and development of the sector. This includes things like detect and avoid technologies, artificial intelligence or AI, data analytics, the propulsion or the energy systems that these drones fly on, and as a whole, how aircraft is being designed. I mean, if you look back in time, actually planes have not changed maybe over the last 60 years already. And there's a lot of innovation that can actually happen in the aircraft design space. So just to touch on a little bit on, the analytics portion, well, data is everywhere now, but the challenge for businesses, for people, is to be able to find out which are the useful data and making sense of those useful data in order to be able to extract value and create new products and solutions out of them. So data analytics is going to be a very important field of advancement that we would see over the next couple of years. Increasingly, drones will be able to find, these cracks, these, malfunctioning systems in, say, a pod with 10,000 cranes. Instead of having humans, you can actually use data to find out, what exactly is going on. And data is really just the first level where you would need to then teach these drones how to be able to identify what is good, what is bad, and when to tell an operator to take action. So we think that, this artificial intelligence in drones or machine learning in drones is going to become more and more critical. And there's going to be a lot of excitement, a lot of jobs that be available in this sector, data scientists, AI scientists. And for instance, in the use of drones for search and rescue in coastal areas, I'm not sure if you're aware, but in Australia, they are actually using some of these drones to help with their lifeguards. For instance, if you are using a drone flying over the coast at a beach area, these drones are so smart today, and they're still learning. They're still in the process of learning. They're so smart today that they can tell, a shark is actually coming. And is it really a shark? Is this shark actually, dangerous to humans? If so, then what would it do? So these are some of the processes, the learnings, the capabilities that the drones are becoming more and more capable of. And once it has identified that, yes, this is, a dangerous shark, it needs to do something. It can even deliver a life vest or this rescue items for it for the people at risk to be able to escape from the situation. Well, besides being able to tell humans what a particular scene is from the data that it collects, drones are also evolving to be able to be smarter and smarter to tell themselves, what is their situation around them. Drones are becoming more and more smart such that the situational awareness around them, where detect and avoid technologies would help them be able to identify if there are hazards around them and that they need to stay away from those areas. For instance, if this drone is flying from point A to point B, and in between during the flight it spots a bird. And this is a very tricky situation because you will need to calculate, okay, is the bird flying towards the drone and how fast it needs to, does it need to avoid it? And if so, how fast and where does it fly to be able to avoid it? So this is a very sophisticated field. It's still being developed as we speak. And this is going to be an area where, it's going to create a lot of good, not just for, drone operations itself, but it is also a great way to reduce, pilot error or human error, which is actually, one of the most common faults that we find when, some of these incidents do happen. So it's quite similar to the advancement of, I would say, these autonomous vehicles, where yes, at the start, these autonomous vehicles may be, a little bit not so good, but after a while, as it continues to leverage AI and learn, it becomes smarter and smarter until one day it is actually able to drive and react faster than a human would be able to. So you can see that this is really a very exciting field to be in. The other area of innovation is in these propulsion systems or the energy sources that they draw their energy from. Today we have seen that in the past drones have relied a lot more on fuel sources, dirty fuel sources, kerosene. But going forward, we think that drones will likely only use clean energy more and more. Different types of batteries are going to emerge, and fuel cell or hydrogen-based energy systems are going to evolve as well. And lastly, on the types of innovation happening in the drone space, these are all the funny types of aircraft designs that we are seeing nowadays. And this is very exciting because drones aircrafts are used for different application areas and in different functions. A certain type of aircraft design or configuration actually works better. There's no one solution that fits all at this point in time. There are drones that are used for deliveries. There are drones like ours that's specifically used in maritime applications where it needs to land vertically on a vessel. And there are also drones that are being developed to be able to fly outside of the Earth's atmosphere at hypersonic speeds for military applications as well. So all this is going to create a lot of new jobs, new career opportunities for young people. In particular, in the engineering field, there's going to be a need for more and more aeronautical engineers, mechanical engineers that can design the aircraft parts, the wings of the aircrafts, the nose of the aircrafts, the electrical and the software algorithms to be able to tell the drone how to react when they meet certain situations. In the operational areas, there will be increasing need for drone pilots, people that are able to fly, not just the typical type of drones, but more and more sophisticated type of drones. And in future, more and more automated drones. Even when drones are automated, they still need people to operate it. Just like in a train system, even though it's unmanned, you still need smart people to be able to operate it. And lastly, in a commercial area, it will certainly create a lot more opportunities in growing the market and growing the businesses for the drones to be used in various applications and various industries. So this is very much what I wanted to share with you today, mostly around what I know about drones and how I see the space evolving. I thought I would also show you a video of the drone that we are currently developing, so you can have a sense of the excitement around designing and building something from scratch on paper and then seeing it fly. So here we go.
Oh, thanks for
everyone.
that. Thanks for that, Nicholas. I think that's a very good sneak peek of existing and potential applications of drones. So thanks for that. We do have some questions, so let's go through them. With the proliferation of drone usage, how do we manage possible privacy concerns that may arise?
It's a great question because we are constantly looking at how this should be addressed, not just in Singapore, but in different parts of the world, as drones increasingly are being used within urban areas and things like that. We understand that according to the aviation regulations, at least in Singapore's context, drones are not supposed to be, at least for the commercial operations of drones, they're not supposed to be flown close to any residential area. And in our application, actually, we decided to stay away from flying from anywhere near residences because we know that that's going to pose a problem. But I think there are two parts. One part is the regulators can make the rules clearer to people that are flying their drones. But at the same time, people have to be more responsible and know what is the responsible thing to do when they fly drones around the neighborhood. So it takes, I think, both hands to clap in this way.
So the laws as well as the operators, they need to be.
Yeah. Usually the commercial drone operators, they would be quite familiar with the rules, and they will not do anything that is outside of those allowable flight paths. It is usually the hobbyists that tend to not be so familiar with the rules and tend to infringe on those.
How do we ensure that drones in the sky do not crash into each other?
Yeah, that's another great question, because today, yes, drones they are flying, they are becoming more and more popular, but we still don't see drones flying outside of our windows or outside East Coast every other day. But this situation will evolve over the next couple of years. We'll see more and more drones that are flying, and that's why in Singapore and also in other parts of the world, different aviation authorities are testing what we call Unmanned Traffic Management Solution, or UTM solutions, to ensure that drones, they know where they are flying, where the other drones are flying, so that they don't crash into them, and potentially the integration between manned and unmanned aircraft to ensure that there will be no accidents happening in such cases. So it's still evolving, but you would imagine that in the not so distant future, there will be this kind of traffic management system very similar to what we have in the civil aviation space today, but not just for the civil aviation space, but also for the unmanned space as well.
And this is a question that comes up quite a lot, Nicholas. So if you were to hazard a guess from today, right, how far away are we to a point where these management systems and technologies are robust enough to allow very fluid drone operations?
I think technology is already quite there, but it is really a question of the cost versus the risk and the value that the system can bring. I would think that probably this would take not more than 3 or 4 years, and we really have a working solution, being able to track where the drones are flying and be able to tell other drones that are in the vicinity where you are flying, so that you don't cross each other's flight paths. And in fact, earlier this year, we have already done some trials together with the aviation authorities in Singapore to sort of enable the tracking of drones when the drones are up in the air.
So, not so distant future. So
probably 3 to 4 years, I hope.
How do we overcome the battery capacity limitations for drones that currently exist?
How do we do it? I didn't quite understand this question. Maybe because of the fact that for our drones, we actually make use of batteries that are already there. So based on our aircraft design, the ability for it to carry 100 kilogram payload over 100 kilometer is actually based on the batteries that are available in the market today. So we are not actually doing any innovation in the battery space. But there is this problem. It's very well known in the car space. For Teslas, for example, you can't put more batteries onto a Tesla car in order for it to go further, because it also means that it is carrying more weight at the start of the journey. So there is this curve where at a certain level, you cannot add more batteries. So that's the same for drones as well. And you can only rely on the materials that are being used within the batteries, how the energy density can be increased to be able to store more of these electrons. But at the same time, there are also new energy innovations happening, such as the use of hydrogen fuel cells, which have much higher energy density.
Your drones. So I think they're referring to air drones here. Able to operate in adverse weather. So
we get this question very often. So because we are, so the simple answer is no, not yet. And it is really an answer that we have told ourselves as well, where we are a startup and we don't want to build the perfect solution before going to the market. A lot of startups make the mistake of wanting to build an ultimate product before they go to market. But actually, what we believe in is in going to the market fast, learning, making mistakes if we need to, and then iterating from there as quickly as possible, rather than trying to build a perfect solution, go to market, and in the end, it can't operate. So today, our drones cannot fly when it rains heavily. It can fly when it drizzles, and it can withstand quite strong winds. But the next drone that we are building will be actually be able to fly in rain.
To answer the question, drizzle, okay, but we are moving on from there.
Yeah.
And also to reiterate your point, multiple iterations and make mistakes, and you improve from there rather than going to a perfect solution.
Exactly.
And this will be the last question, Nicholas. How will these drones navigate Singapore or anywhere else autonomously?
Good question, because I think people think that drones, in a way, when they are autonomous, they are allowed to operate anywhere they want and fly anywhere they want. But actually, that's not quite the case, at least not in the near future, I would think. Maybe not even in 5 or 10 years. Today, when we say that drones operate autonomously, we say that they operate autonomously within a certain set of boundaries that we set for them. The easiest one is, say, for instance, I set from point A to point B. This drone will fly from, say, PIE in Tampines to PIE in Jurong, and it will only take this flight path by itself. And that's how it navigates autonomously, and it will not go anywhere else. Likewise, in the use of drones for our space, we confine the drones to only flying within this part over waters, where the drones will not be able to fly outside of the area by itself.
Okay, so for time being, fixed path first.
Yes.
Okay.
Yes.
Oh, thanks for that. I think we got some time. I'll have one bonus question. I think some of the earlier sessions, some of the students they have, which is, do you, okay, and this is about internships, so related. Do you foresee or observe talent gaps 5 to 10 years now, if it was for those who are considering a career in aerospace?
Wow, that's a great question, because I would love to find people that are passionate and people, I mean, engineers in different fields to come and join us, whether as full-timers or as internships. So yes, the answer is yes, internship positions are open. And not just in 5-10 years, I think there's already a talent gap now, because it's such a new area where there's so many innovation happening in detect and avoid technologies, in hydrogen fuel cell systems, in new types of aircraft design. Dealing with regulators, there's so many things that are happening that we are also trying to learn along the way. So it's actually a great time for us to think about what are some of the roles I would be excited about joining, how I can acquire those skills, and most likely, I would be a pioneer in that space, because I'll be one of the first few people in the world to be involved in drones at this point.
So the direct answer to this is yes, they are looking.
Yes.
There are opportunities. Good.
Yes.
Okay, Nicholas, we come to an end. I'd like to thank you very much for being here with us and sharing with us your insights and your information. So thank you once again.
Thanks, Johnson, and thanks everyone for your time. Thank you.
So to the audience, if there are any more questions, please put them through to us on YouTube for Aspire Incubation Labs. All right, so that's all for today. And the weekend is coming, and we'll delve into space topics, a session each on Saturday and Sunday. So tomorrow we have Mr. Ng, who is CEO and co-founder of New Space Private Limited, who will be discussing with us an affordable and accessible satellites that normal folks like you and me can use for space exploration. So stay tuned. That will be tomorrow at 3:45 p.m. And before we end, on the 1st of July, we have invited a very special guest on the show, NASA astronaut, Jeff Williams. Let's watch this highlight.
speed, standing by, and liftoff. Jeff Williams, Alexei Yachtin, and Oleg Skropochka launching to the International Space Station.
This will be on the 1st of July, the conversation with Jeff Williams. So if you're not already signed up, you'll be prompted to do so after this session. And there is also a link to sign up right now in the chat. So I'll see you then. So thank you all for being a great audience. That's all for today. Thank you very much. Please give us your feedback and I look forward to seeing you at the next one. Bye-bye.